this session on regular expressions. I intend to start with basics, what the regular expressions are, how they are built, what we can use them for, and then show some examples of good usage and some example of bad usage that should be avoided. We'll take a look at how everything is implemented in Delphi. But most of the time I will stay in other tools, as you'll see, because the problem here when you're using regular expressions is really not of the coding nature. The code that uses regular expressions is relatively simple. The problem is how to build them, how to declare them, and how to manage them. And this is actually not the problem of Delphi or Delphi RTL, but of other tools, which I will show. So let's start. The biggest question, and quite hard to answer, is what the hell the regular expressions are. In short, they are a specialized language that describes strings, but not specifically the strings like text, but strings in a more high-level description. So in the language of regular expressions, I could, example, think of this text as of quote followed by lots of characters and commas, followed by and also quotes and terminated by a quote. So I don't think about, usually, I don't think about specific characters like A and F and so on, but of classes of characters, of patterns, of things that match text, we say. The simplest expression, if you worked with DOS at any time in your past, you know, you could say dir space star dot star, and you will get a list of all files. And in this is not a regular expression, it's similar, but the star in this example represents any text. So we'll do similar things here. Everything started in the Unix world with old command line editors like ed, where they introduced a syntax for searching in the text with stars and question marks and so on that got more and more powerful. And most of the old-time flavors, we call them, because there are many almost compatible versions of regular expressions. And then there is one which is quite different. They all started in Unix world. Then, as you see, they moved into other projects. So all these environments, all these languages, they implement regular expression syntax, each of them in a slightly different way, with the exception of JavaScript, which does it quite differently, not just a little bit different. I'll be focusing on Delphi. I'm just mentioning others from time to time so that you know where the problems can be if you develop, for example, also for JavaScript. But I'll be focusing here. So Delphi uses PCRE, which means Perl compatible regular expressions. It was a library built to mimic the behavior of the Perl language. What can they be used for? As I said, we can match strings, as in dir example from DOS. We can say, does this text match a form of 4 groups of numbers delimited with dots, the IP address. We can also search in text. We can say, does this pattern occur anywhere in the text? Not that it matches full text, but is it present here, here, here? We can, if we find something, then we can replace. And replacing, we can say, please reuse something that you found with the regular expression. And the last one, which is usually forgotten, is when you read about regular expressions on the net, is that you can use them to split string into array of shorter strings, which is something that's quite common in JavaScript, for example, not typically done a lot in Delphi. But there is a split function somewhere in sysutils, if you'll take a look. There are also some limitations. There are almost in all cases slower in execution time than the code you can write by hand, and which solves specifically just the case you are solving. It's because regular expressions are evaluated and matched by some specialized engine which can handle everything, and because of that is usually slower than some specialized code. But then they're also much faster to write. You can write regular expression in a few minutes and test it, and you could spend writing Delphi code to do the same task. You can spend a day maybe. Depends on how complicated it is. If the regular expressions are complex and the text you are matching is long, and if they are written incorrectly, I will go back to that later, the engine which matches regular expression to a text can use lots of time and lots of memory. I will show two typical problems which usually occur in code later, so you'll know what to take care of. And you cannot do everything with them. You cannot parse generic HTML with the regular expressions. It is simply not possible. But you can, for example, parse some subset of HTML that occurs on a page you are downloading. You know the page is always in this specific format. I will use regular expressions to extract data from it. That's quite possible. It's just not possible to write a generic HTML parser. And almost all regular expression implementations, including one in Delphi, are UTF-8 based. So if you are doing lots of string copying and comparison, they are converted every time if they are not originally in UTF-8. So this can take quite some time. But here we cannot do anything, I think, to fix it. As I said, everything started with editors, like Ed, and then it got implemented basically in any editor that there is on the world. The regular expressions are supported in search tools like grep or extended versions, which will match list of files and try to find some expression in them. For testing, it's quite nice to have an online tool. So you go to this one. There's lots of online tools. This one I especially recommend because it supports the Delphi flavor of regular expressions, that is PCRE. Most of online regular expression tools only support JavaScript because they're written in JavaScript, and they just use the runtime engine of JavaScript to test your expression, but this one works with PCRE. They work so that you paste a text in one box, write a regular expression in another, click a button, and it will say, okay, matches, I found it here, there, or it didn't match. And these two tools I really, really recommend if you will be spending any time with regular expressions. Those two tools, they're not free. They were written by Jan Goiverts. I hope I pronounced that approximately correct. The guy who wrote TPerl regex component for older Delphis, and the guy whose regular expression code is included in Exit 2 and Exit 3 because Embarcadero licensed the regular expression engine from him. He knows what he's doing. And he wrote two wonderful tools, which I'll be showing today a lot, which bought in a package together, I think cost 50 euro, which is not something that would hit your wallet a lot. And if you're using regular expression more than once a month, I recommend them. Oh, icon here to remind me that I should switch to demo mode. So I will be using regex body most of the time today. I will just show regex magic. This software is designed for people who don't really want to remember how regular expressions are put together. As you will see, regular expressions look like a line noise. They are hard to read, full of special characters, and it's easy to make mistakes if you're writing them. In regex body, you can say, you can define your expression, your match, descriptively. As you say, okay, I will need a field which is not repeated, which will match a number, and it should be optionally prepended with plus or minus. I will allow leading zeros, for example, and the tool will generate a regular expression for you. Or I can say, I only want numbers from 1 to 1,000, and you get a different regular expression. And just ignore what's written here. And plus, it has a library of patterns. So you can, for example, say, OK, I want this to match IPv4 address. You'll get regular expression for IPv4. And then you go to the Use tab, and it will create Delphi code for you. So you can just copy and paste it into your application and forget everything about these strange numbers and symbols written here. It will also do other languages, not just Delphi. So I can, for example, create JavaScript match or PHP if you're using HTML5 builder, or Prism, or this is Prism, Delphi.net, and so on, and so on, and so on. XML schema, maybe. OK, this one is not really supported, I see. So let's go back. And it will do different things. So you can say, I need a code that tests if pattern matches my string. Or you can say, I need a code that will search inside larger string, find an IP address, and get me back the result, and so on. So it comes with very many predefined templates, which will do which will cover most of your needs. As I said, Jan wrote the T-Perl regex component back in, I don't know, Delphi 5 times, something like that. It was supported up to 2010, in XE, not in XE2, in XE. It got included in the standard runtime library because Embarcadero licensed it. So after XE, you don't need this add-on. Before XE, you need this component which you drop on the forum. The behavior is very similar to the new behavior. I will be showing the new units and new approaches. The core unit basically just wraps this component, wraps the PCRE library. And the regular expressions unit adds high-level wrappers which are simpler to use. And I will be showing those today. And I'll start with an example. Text search, very simple regular expression which matches 3 different variations of the handle, the composer. his surname is spelled in 3 different ways, depending on the books, depending on the material. And this is a regular expression which matches all 3. So H is H. I said before that typically you don't specify exact characters in the search, in the regular expression, but you can do it. Same for NDEL. Whatever is in parentheses is called a group. In this case, group was only added to limit the scope of this pipe, which is character that means or. So we want to match a with umlaut or this thing on the right. Pipe, it would match HA or AE NDL. So that's why the parentheses are important here. And the last trick, question marks means 0 or 1 occurrences of the character before it. So in this case, we accept A or we accept AE. So that's how the A case is handled, A with umlaut case is handled, and AE case is handled by using all this. And the Delphi code would say if TRegEx, which is a class from the regular expression unit, which implements a class function isMatch, if isMatch some string to this. So if this expression matches my string. So I'll switch to this other software, RegEx Buddy. This one was designed more for testing, for regular expression testing and debugging. So you start by writing a regular expression. Oh, yeah, I skipped something, yes. So this is again a regular expression, which is alternative to the one above. It says match the first string or the second string or the third one. So this is quite simple to understand. This one not so much. And I have here the long-winded version. And down below I have the test string. And I can see that 1, 2, 3 occurrences matched. And for example, if I try to add one more E here, it will not be matched anymore because the string is not listed in the list above. The second case, okay, in this example I wrote it as A or A with umlaut or AE. Again, matches the same, or I said I could do A plus optional E. It will work again. Here in this software, I also have a library of regular expressions, which is quite bigger than the one in regex magic. I can also convert regular expressions to code. Again, I can do this for TRegEx component, for Delphi, and so on and so on. Again, I can do different jobs using different templates. So I said before, I can write characters like H, A, and D, and regular expression engine will try to match them by comparing them to the text. Actually, any ASCII character can be written into the regular expression. Most of them are just compared as normal characters, character by character, with the text you are matching against. But there are some special characters called metacharacters, which have some special meaning. And when you write complicated regular expressions, they will contain a bunch of these characters. And that's why everything looks like a line noise at the end, and it's hard to parse, hard to understand. So we have meta-characters which mean something, which are interpreted in a special way, and we have literals, which is everything else. And actually, regular expressions work on Unicode. So I mentioned ASCII before, but you can write any Unicode character in a regular expression. You can match against Unicode and so on. And let's start with the most basic one, which is called escape, backslash. If I want to find one of those characters in the text, like $, I cannot write $, because it has a special meaning, but I can write $. So I quote it in a way, and it will be interpreted literally. Again, if I put backslash before letter, I get special meaning. I get escape characters, they're usually called. You can forget about them most of the time. Maybe those two will occur in your expression sometimes, this new line and carriage return. So it's a character of 10 with code 10 and character with code 14. Regular expression that matches delimiters, semicolon, colon, comma, and dot. Of those four, only dot is something special, and I had to escape it with a backslash so that it's here. So it's found here. If I remove the if I remove this backslash, I get something weird, because dot means any character. So any character is now matched by this dot. If you will decide to go deeper into this area, again, I recommend, I'm returning back to the same guy. He knows everything about regular expressions. This book, Regular Expressions Cookbook, is not Delphi specific. Actually, it talks relatively little about Delphi. It contains a lot of recipes. It's written in a problem recipe form. And recipes are mostly done for Perl, which is good enough, because Perl regular expressions match Delphi syntax almost exactly. .NET, JavaScript, and I don't know, a few other things, I think. But he also has free version on the internet of part of this book. So you can get a pretty detailed tutorial here, which will describe all variants of escape characters. I only mentioned two. You'll find everything else here. All special characters are explained. Everything is here. So very much recommended resource. OK, so let's continue with the syntax. A concept called character class in the language of regular expressions is introduced by a square bracket and is terminated by a square bracket, and means any of characters inside. So this expression will match A, B, or C. You can use ranges with the minus character. So this is from A to F, from A to F. If you don't specify explicitly, in regular expressions, small and capital letters are not the same. But you can force this behavior later. Or you can say not whatever is inside those brackets. Caret is actually not a meta character. So if it's found anywhere in a regular expression except immediately after a square bracket, it will be treated just like a normal character. But in this function, it means not. So if you want to add caret to such a list, if you want to say, OK, match A to F, 0 to 9, and a caret, it's best to put it at the end, not at the beginning, and then nothing goes wrong. It's just some peculiarity of regular expressions. Most utilities that come from Unix are weird in one or other way because they were extended in layers by users, by people, not by some designers, not by some explicit purpose. So as we saw before, I can use pipe to specify alternatives, like in the handle case. And I can use dot to represent any character, any at all. Then we have some very useful shorthands, so you don't have to type these complicated long expressions. You can use \d to specify any digit, or \D to specify not a digit. You can use W to specify word characters or not word characters, where word is really a list of characters that are usually valid identifier names. In Delphi, for example, you can use letters, numbers, and underline in variable names, class names, and so on. Similar in Unix, in Perl. So this is not really a word character from natural language, but word character from computer language, and the limited one that only understands underline, number, or letter. And we have a space, or not space, which expands. Okay, what it expands to is now dependent on the implementation, on the flavor. But in most cases, it will mean the same as ASCII space, tabulator, carriage return, or line fit. Then we have meta characters that are called anchors because they attach to some position inside the text and they don't move around, they stay there. And the first is caret. Oh, sorry, I said before caret is nothing special. I was wrong. I apologize. Caret is really a weird stuff. It will match start of line, but not if it's inside the character class, where it will mean not if it's first in the list, but it will mean ordinary character if it's later in the list, so mess. Or you can use \A to say this must occur at the beginning of line or at the beginning of text. Just keep this in mind. I'll return to this later. You can match end of line. So this part of regular expression must occur at the end of line or at the end of text. And here the PCRE syntax supports two different versions of \Z, which I never remember how they differ. The difference occurs only in a very specific situation if you match multiple lines in a text and there's an empty line at the end. So it ends with carriage return, line fit, carriage return, line fit. And then there's some specific difference between this and this, but most of the time you don't need to know that. And then we have very interesting anchor /B, which will match any place, not character, but place, position between two words. Sorry, between a word and a non-word. So as I said before, a word is a sequence of letters, numbers, and underlines. And if you type ABC and then dot, for example, this position between the C and between the dot is called word boundary. So the word ends here. And /B will match exactly this position. Then we have the Unicode support. Here is where the things get complicated. But let's say you can match single grapheme, not a single character code, but basically character form. You can specify specific code points. For example, 2122 is trademark character. You can specify Unicode categories. In Unicode, every character is assigned to some category. So you have characters that are letters, characters that are numbers, characters that are delimiters, characters that are white space, and so on. And this \P of n, this is basically the same as \D, digit, but it works for other scripts also, not only for the Latin script, and it works for for any Unicode digit. And I can also say, please match only the stuff that's written in Greek or the stuff that is written in Hebrew, and so on. You have lots and lots and lots of options. But as it's usual with Unicode, it's hard to work with it, however you approach it, so it gets complicated, with or without regular expressions. Now we are moving to funny parts. I used a group before in my first example to limit the range of the pipe character to A or AE only. But brackets, parentheses are more than that. They will also capture, that is, remember the part that's inside them. So if you want to find regular expression in a text and then extract something outside, if you, for example, this is digit followed by digit followed by digit. If I want to get first 3-digit number in my string outside, whatever that number is, I will wrap this in a group. And this group will tell the regular expression engine, please store this so I can access it later after the code executes. And you can also use groups for search and replace. In some cases, you don't want this to be stored, typically because you want to optimize the execution time of some complicated expression. And in such case, you can put question mark colon at the beginning, and this becomes something called non-capturing group. And you can also give a group a name, so which is nice if you are capturing different groups from the code. You can say, please give me content of group digits, not group. If there are more than one group in the text, they can be either referenced as numbers from 1 to 99 or by names. This comes from the library. This complicated regular expression that matches 1, 2, 3, 4, 5, 6 most commonly used credit card numbers. And it will nicely put them in an appropriately named group. So you can say in your code, if group MasterCard is not empty, okay, I have MasterCard number, I can get the value of this number outside. So I can say TRegEx.match, that's long expression, and then access group, for example, group Visa, and get the value of matched text. So I already mentioned groups are either numbered by or named. And when writing the regular expression, I can refer to the content of a previously found group. So in this example, this is group 1. Regular expression will match 3 numbers. And I can say then those 3 numbers must repeat again. So whatever you found here must repeat one more time. Or I could use a reference by name. So DDD, here it will match 0, 1, 2, but then it's not repeated. But here it will match 1, 2, 3, and it's repeated again. So this is a hit. If I remove something, if I add something, it doesn't match. I could say, okay, it must repeat again. And again, this is a match. Mostly, this notation is used in search and replace, not when finding things. But again, I'll come to this later. Or you can use the named notation. So this example is too simple to see any value in such behavior, but okay. You can say, okay, capture group, name it digits, and then I want to have this group again, the group with the same name. Here it looks stupid if you have a big regular expression like the one with the credit card before. groups, named groups make much more sense. If you maybe noticed, all of the time since the beginning, with the exception of the handle case, all regular expressions matched only one character all of the time, because I was using either a range or a class or /d functions that, or sorry, characters, meta characters that only match one character, not some longer repetition of characters. So with repetitions, everything becomes useful. Without repetitions, we will not be here today, because nobody would be using regular expressions. I can say, so you specify repetition by putting the, however this bracket is called, I always forget, and the number of repetitions inside. And this will apply to the object that precedes it. So if I say /d 42, that would mean 42 digits. If I say character class 18, this means from 1 to 8 occurrences of this hexadecimal number. Or I can say at least 17 and however more. There's 3 possibilities. So exact number of repetitions, range of repetitions, or open range. And if I go back, my hexadecimal matcher suddenly became much more useful, because now I'm matching optional $. I already mentioned before that question marks means 0 or 1. I had to use backslash to escape $, to $sign to not mean the end of line. A to F or digit 1 to 8 times. So in this long expression, I have now 2 matches, because it was too long. There are more than 8 repetitions. If I also include the word boundary, I get something that's quite useful already. A regular expression that will fetch me everything that looks like hexadecimal number for my text. Okay, there are still some misses, but okay, that's the most you can do. Again, we have some shorthand notations. I mentioned question marks, which means 0 or 1, whatever was before. Plus sign means 1 or more. So there has to be at least one occurrence of whatever was matched. And star means 0 or more. This is the most flexible of everything. Then we have some variations. This is, again, hard to explain. Okay, maybe not so much. If you write dot star, dot means any character, star means any number of repetitions. If you write left bracket dot star right bracket, you would match HTML tag, for example. Yeah? The star character, also the plus character, are greedy. That's official notation terminology. They try to grab as much as possible. So regular expression engine will say, okay, this angle bracket will match my angle bracket, less than, and then star will grab as much as possible, and then it will end with finishing bracket. And again, this is working line by line at the moment, not over the whole string. And that's why we have variations called non-greedy, which will take a small number of characters as possible, not as large. So the same goes for the plus. And then we have something called possessive form, which you may safely ignore at the moment. Possessive form means once that you match this, don't go back. because regular expressions use something called backtracing. It will try to match your regular expression element by element. Then if it finds out that it cannot complete it, it will go back, try to match it a different way, go back, try to match it a third way, and so on. But if you use the possessive form, once that it matches, it will never go back since that point. It can be used to optimize some complicated stuff a lot. Okay, then we have modifiers, which I mentioned before in passing. You can say, please treat my regular expression as case insensitive, so big, small and capital letters are the same. You can use a mode where the dot, which means any character, also matches line breaks, or the mode where the dot character doesn't match line breaks. So it depends whether you are processing text line by line or as a whole. And again, you have the multi-line mode, which specify whether the character and dollar match beginning and end of the text or beginning and end of each line. Well, in search and replace, you can refer back to the groups. You can say, I'm talking now about the replace expression. You can say, use the contents of group 1 and insert it here. You can say, use the whole match, everything the expression matched is called \0. You can reference everything by a name, and then there's something called left context and right context. This is the text before the group, and this is the text after the group. But again, you can forget this. But this is useful and important. Okay, I have some examples here. How to match username, how to match most of the email addresses. Maybe this one is interesting, IPv4 address. Says any digit 1 to 3 times, and then a dot, escaped because dot is meta character. And all this stuff repeats exactly 3 times, and then I have the last group, which is not followed by a dot. Then there are bad examples. This I got from Delphi.about.com, and I really hate it. This is something I would never do with a regular expression, because who can say if this is correct? I don't think there's anybody in the world that can say this is correct or not. Write 20 lines of code instead of writing such stuff. As I said, don't parse HTML with regex. It's only, you do this if you know that HTML pages are well formed, you know what to search for in them, and so on. And I said that sometimes regular expressions can behave really, really badly. This is a specific example of something called catastrophic backtracking. And this one says at least one x, but any number, followed by at least one x, but any number of them. And everything is repeated at least one time, but again, any number of them, end it with y. It's example, but okay. The problem with this is that it will try to work like this. Okay, I will match almost everything with the first x, and I will match the last x, and or something like that. Okay, it will match half, and it will use plus to match the rest. But there's no y. Oops, what to do? Okay, I will go one character back. I will try, and I will match, I don't know, 9 x's followed by 1x, repeat it twice, followed by y. Okay, sorry, there's no y. What to do? I will go one character back. And you get a combinatoric explosion. You get, if you add one more x here, at some point, either the regular expression engine says, sorry, you're an idiot, I will not do this, or it will lock your computer, eat all of the memory, and stop processing. So there are traps. Okay, Delphi IDE. If you watch the search and replace dialog closely. There's a checkbox called RegularExpressions, but the syntax that's implemented there is different than anything else on the world. It's documented here in this link. For grouping, you need to use this kind of brackets, which don't function as they usually do. Question mark is not supported at all, so you cannot say 0 or 1 occurrence of something. And pipes are also not supported. But still, it is useful. I will not show the demo because we don't have time. For example, if you want to find all if defs and if not defs in the code, you can say, OK, $, which must be escaped. If n 0 or more times, it will also find if n def, but probably you don't have those. Or this is an example which replaces if def or not def Win64 with if def or not def CPU x64, and says match if any number of fans, this time grouped, def Win64, and replace it with if the content of this group, and I used wrong brackets here. I should use the squiggly ones. So it will replace if def with if def and if n def with if n def. It can be quite useful. It's clumsy, but OK. OK, so thank you for coming.